Assalamualaikum and greetings. My name is Muhammad Zain Afan bin Abidin. Matric number CA20092. Our group 8 will explain about the case study 8, which is University of Delaware that needs to change their storage device to a new storage called Fujitsu 4000 Ethernet. Firstly, I would like to introduce our group members, Adam bin Muhammad Yusuf and Danish Rao, anak lelaki Siva Rao. I will explain to Danish Rao to explain more about the introduction.
Good afternoon and good day everyone. My name is Danish Rao and today I will be presenting about the introduction and the issues to the case study for the subject BCN 3043 Network Service Administration, and I am from lab section 1B. So beginning with the introduction, the University of Delaware, located in Newark, Delaware, is classified as the largest university in Delaware, which consists of approximately 19,000 undergraduates and 4,200 graduates currently enrolled in the institution. Currently, in the present time, the University of Delaware was ranked 352 globally according to the Times Higher Education World University Rankings. The university is organized into 9 colleges and 5 schools that are open for enrollment. However, in this day and age, the University of Delaware has planned to incorporate an enterprise-class storage solution to accommodate the storage needs of all critical academic as well as administrative data. So next, I will be presenting about the issues related to the case study. So the first issue is due to the high amount of data that needs to be stored, the performance of their current storage solution could not cope with the demands of the university. The older storage solution would require data to be backed up by Oracle databases that support applications like web servers and email servers, as well as a full library catalog. The university would run backups around the clock by storing 1 week of data on a disk, and then it is copied to tape. This in turn causes a delay when users want to retrieve any recent data, therefore a solution has to be created to ensure quick access to recent information is provided. Well, the next issue is the serial advantage technology attachment cables were used to connect the storage devices. The use of SATA cables is one of the slowest forms of storage interface when compared to other interfaces. This is because the SATA cables are not efficient when used with multiple drives, as each drive has to have a specific connection to the motherboard. The single controller and path into the drive architecture poses limitations as in data redundancy. Not only that, SATA cables have a lower bandwidth when compared to other types of cables. In the future, SATA cables will also require different IDE connections, which can pose an issue when trying to update in the future, as the disk drives have to be SATA support compatible. Third issue is the need for high performance and backup and recovery. Before the introduction of the Ethernet 4000, some issues the university were facing was when the backup and the recovery was slow. This is because data was backed up from disk drives to tape, which was not efficient, as the data on the tape has to be mounted in position. The time needed to copy the data to the disk tape was very slow, and not only that, there are cases when the tape device can be damaged. Errors can also occur if the tape is written too slowly. And the last issue is the storage system needs to have a good scalability. This is an issue with the older storage system, as the scalability was not planned from the beginning. Therefore, any future plan to increase scalability to match the workload would be expensive and not cost-effective. The new storage system selected by the university has to be able to provide scalability, as it is important to consider scalability before implementing in the new storage. The option for scalability will allow the university to increase the amount of maximum data stored, which can be important if there is any rise in the amount of data that needs to be stored, which could be true for the type of data the university has to store. And that is all for me. Thank you.
Hello, my name is Adam and I will be presenting about issues that Athena solved. The first issue is performance. Athena 4000 solved the issue by using the disk driver and FC compatibility to increase the performance, redundancy, and the storage capability. Other issues is backup and recovery. This issue is solved because the Athenos 4000 support double parity in addition to data block verification RAID 6. In essence, RAID 6 is a RAID configuration that works by storing data over many drives. Redundancy in data is aided by this. Additionally, even if two disks dies, the RAID 6 RAID configuration may keep the data intact due to its ability to save data for lengthy data retention priorities. This RAID strategy is excellent for achieving data, archiving data. In essence, this RAID 6 configuration can withstand several failures without any data loss. And lastly, the issues of scalability. The institution places a very high value in scalability, and the Athenos 4000 offers that choice with its formidable CPU and capability to scale up to 480 TB of data storage. When compared to alternative storage system, the core processor's operating speed of 2.83 GHz quad processors result in a much higher level of performance. Storage shelves can also be installed in order to expand the quantity of data that can be stored. Doing so can improve the scalability necessary in the future. Next is implementation and configuration part for the selected solution. Firstly, establish a LAN connection between the PC and the Athenos and access the Athenos website. Secondly, setting the RAID and setting host menu. The third step is select the RAID group to be added, and then select all the disks to be created in the RAID group and click the set button. And lastly, click the OK button to confirm the DES, and this to configure, click the RAID group link. Numerous crucial steps must be followed through the development and configuration process to ensure that the Athenos 4000 storage system is appropriately set up and configured to meet the organization's specific demand. Firstly, the data migration. The information will be moved from the existing storage system to the Athenos 4000. This will need planning by the migration and organize the data for moving and testing the migration process. And then testing to ensure that the system satisfies the requirement of the plan for performance, reliability, data recovery. It will undergo the comprehensive testing. This will entail monitoring performance, evaluating data backup and recovery, and verifying the accuracy of the data stored on the Athenos 4000. After that is training. The end user and the IT staff will receive a training on how to utilize Athenos 4000 storage system, including how to backup, recovery, and the recovery data and monitoring performance. And lastly, maintenance and support. The Fujitsu team will provide ongoing maintenance and support for the Athenos 4000 storage system, including fixing any problem that may develop and supply update and upgrade as necessary.
Next is for implementation and configuration part for the selected solution. Firstly, we use a direct browser access to Athenos Manager backend program. First, we need to establish a LAN connection between PC and the Athenos 8000 or Athenos 4000 user port, and then we start the web browser to connect the PC directly to the Athenos 4000 user port. A LAN straight cable is required. And then we input URL into web browser's address bar, and we specify HTTP Athenos 4000 IP address. The title screen of the maintenance program will appear. This is the example of the backend program, the Athenos Manager software. And then we setting the RAID, setting the host menu. This is the example. And we select RAID group to be added here. And then we select all the disks to created in the read group and we click the set button. Here is the example of all the selected disks. And then we click the OK button. And when the process is successfully completed, the create read group result screen will appear. This is the example. In the circle, we have seen the result. Next is features of Ethernet 4000. This is the size of the Ethernet 4000. So this device is very fast and cheap, and Ethernet 4000 is a modular, highly scalable storage consolidation platform. It has a 418 terabyte of data storage. The core processor can operate at 2.83 gigahertz quad processor, so it is very fast for a storage. And the next feature is RAID 6. Let's see another feature of Ethernet 4000. It is the data integrity potential of the Ethernet 4000. Data integrity is an important aspect to any data storage system. The Ethernet 4000 provides data block checking as well as the double party support RAID 6. RAID 6 is essentially a RAID scheme that functions storing data on multiple disks. This helps in data redundancy. Not only that, the RAID scheme can retain data if the two disk failures happen at the same time. Here is the RAID 6 representation. In the picture, we can see. And then another feature is eco mode. In bracket MAID, MAID. Fujitsu refers to power conserving using the MAID technology as eco mode, which stands for massive array of idle disks, MAID. Lowers the power usage by turning off disk drives that are not used as often. In the array, eco mode can be selected for any kind of disk or RAID group. After being inactive for 30 minutes, drives are spun down to use less energy. When any volume or any drive is read or written to the device in a spun down RAID group will once again become functional. And then reactivation can take anything from a few seconds to 3 minutes, depending on the drive design and any kind of the timeline of an eco mode use case is depicted below. Here is the client make use of pull of large capacity SATA disk. Here is the example photo of how the drive idle. Here we can see in the 11:55 p.m. the drive idle and spin down. And then at 12 a.m. drive spin up per schedule and backup is performed. And after that backup complete at 3 a.m. and 3:30 a.m. the drive spin down again. And then at 9 a.m. It required the restore. And 1 minute after that, the idle drive spin up automatically after 1 minute. And then after 30 minutes, the restore is complete. And at 10 a.m., the drive spin down again. This is the cycle of the eco mode. Eco mode utilizes a setting in conjunction with RAID group activity to determine if RAID group should be spun down. If there is no activity and the setting indicates the group should be spun down, then eco mode take effect. If either of these two conditions is not met, then the group will remain spinning. Eco mode utilizes time frame for a specific RAID group, and RAID group may be enabled for the following time frame. We have every day, which the mode is enabled every day from the specific time to another specified end time. And then for every week, the mode is enabled from specified start time to the specified end time. And then it's the same until last access time. Last access time, a specific amount of time has elapsed since RAID group was last access. This may be set to 10 until 60 minutes, default in 30 minutes. And then the next feature is Fujitsu Ethernet disk encryption. And the security of corporate data has become increasingly important as a result of legislation such as personal information and protection laws. And is restricted to authorized user, and any accidental and unauthorized access to sensitive data might be blocked. And then high grade encryption is used for the Ethernet to block unauthorized data access. This includes the support for Fujitsu proprietary encryption with high process performance. It uses 128-bit and 256-bit AES. And then additionally, Ethernet supports self-encrypting device SED. Instead of the firmware, the disk drive in the instance use hardware encryption. Here is the example photo of how it works. The mechanism of the self-disk and self-disk encryption. And then for the key management group in which SED are registered, the necessary authentication keys are given. When required, a required device is given authentication keys produced and kept by a key management server. And we can see here how in the picture we have the self-encrypted disk, we have the unencrypted drive and drive which have the data encryption. Next is advantage and disadvantage of Ethernet 4000. First of all, is the availability and business continuity. So the wide range of data volume and protection offered by Fujitsu disk storage system enables business to provide consumer with highly accessible storage both within a single system and across various data centers. For instance, the block guide feature add check code to data and verify data at the channel adapter and device adapter to ensure operational accuracy and end-to-end storage integrity. Data availability is ensured by the component redundancy, by swapping failure isolation, multiple path access, and as well as intra and inner system volume copy services. So for the Delaware service backup and data preservation, this makes it possible to save data without worrying about the data loss or whenever there is a data violation error or failure in entering new information of students. Next is performance and scalability. So similar to its enterprise sibling, the design, it was to meet the same availability and performance standard. Just like Ethernet 8000, the highly availability of operation in the Ethernet platform is made possible by the active controller, mirrored cache, fully redundant backend, and option for the local and remote data replication. So for the University of Delaware, they may use this feature to process data quickly rather than the old ATA disk speed, which takes longer to process data. So the comparison is vastly different in terms of efficiency in doing each task in the system, which every university student has struggled with before due to the slow data access. So for the disadvantage, of course, the cost to implement this Fujitsu Ethernet 4000 is quite expensive compared to other alternative because there is maybe some more cheaper storage device, but of course all the functionality meets the requirement from the University of Delaware in terms of scalability, availability, and security. But the university need to have a good budget range in order to use this storage device. Next is it needs an expert in hardware management in order to configure the Fujitsu Ethernet 4000, because if there is a mistake such as power loss during the process of data integration, there is a risk of data loss for the University of Delaware database. Next is the topic related to the case study. Of course, first of all, the topic that comes to mind is from Chapter 7, Distributed File System. So this is because in the case study, the University of Delaware used a distributed database and wanted to back up all the information from the database into a new storage called Fujitsu Ethernet 4000. The DFS can collect files from the branch office and then replicate them to hub site, thus allowing the file to be used for a number of specific purposes. Critical data can be replicated to a hub using the DFSR and then back up to the hub using the standard backup procedures. So this statement show that how University of Delaware implemented data migration to backup from the old ATA storage to a new Ethernet 4000 storage using the DFSR technologies. That's all from our group. Thank you.